hopefully there's not too many hangovers in the room. I noticed a bunch of you managed to make it to the keynote. I'm always impressed with that. On the second day, if a bunch of people manage to drag themselves out of bed to the keynote. I'm James Turnbull. I'm here to talk about how I learned to stop being afraid and love the JVM. Who I am, I'm an author. I've written a bunch of books about technology. I've been in the open source community for more years than I care to think about. The lack of hair and the grey should give that away. I have a funny accent, which is more important in America than it is here, because there's lots of people with different accents here. But Americans need to be told that I'm actually Australian, not English or Irish or South African or New Zealander. And I work at a company called Empatico, where we are an educational technology company, and we build a platform that connects primary school students together to help them build empathy skills, something that's kind of lacking in the world at the moment. This is the pitch part of my talk. I've written a bunch of books. This is a more recent one about Terraform, and there's another one about monitoring. This is how I pay my mortgage, or at least buy drinks, so please do have a look. So who are you folks? How many people here consider themselves a developer? Okay, I was pretty sure there was going to be a stronger. How about a sort of operations sysadmin person? Okay, there's one hand, two hands, okay. DevOpsy thing, that's probably a cooler word. SRE, okay. Anyone do everything including the cabling and fix the printer? Yeah, there's always one. I'm sorry, dude, I've been where you are. I don't fix printers anymore. I put that in my new contracts. So what's this all about? Well, it's about two real concepts. The first one is functionally about the JVM and a little bit about Java. And it's about my experiences talking to a bunch of folks about the JVM and what they thought of it. And it's also about mythology and how people build systems and come up with ideas or have ideas about particular architectures based on previous experiences, not necessarily their own, but shared experiences. Broadly speaking, it's kind of called mythology. And I think particularly for technology platforms that have been around a long time, Java is 22 or 23 years old this year. So it's no longer a teenager, it's now a precocious 20-year-old, in its precocious 20s. That's probably about the length of my professional career, I think. Maybe I've been an engineer about 25 years, maybe. And it is the second most commonly used language in the world. That's an IEEE statistic. I'm not sure. I think probably because on GitHub and things like that, it's probably something like JavaScript or something like that, because most Java code, I suspect, is proprietary, and it's located inside enterprise organizations where there's 20 million lines of J2E code that keep track of your mortgage. The most popular language, by the way, is C, which surprised me, but this is the IEEE statistics. I can imagine that there's many millions of lines of C code out there. And so I've been using the JVM and to a lesser extent Java for some of that period. I think probably the first JVM based project I worked on was maybe in the early 2000s, which again dates me. But recently, one of my other roles is I'm the maintainer of Riemann, which is an event processing system written by Kyle Kingsbury. It's written in Clojure, and so it runs on the JVM. So I talk about it at conferences a fair bit, and I've written a book about it. And almost always at the end of the talk, there's a guy probably with a longer beard than mine with a bit more grey in it and a grumpy look on his face, puts his hand up and says, I can't imagine using your monitoring or your event processing solution because the JVM is crap. And I'm like, okay, that's a very broad generalization. Tell me why. Tell me what your experience is there. Where did the JVM hurt you? And so I get this person. They say, well, one time in 2006, at 3 o'clock in the morning, this Java-based application crashed out, and the JVM was impossible to diagnose, and I had all these problems. And I'm like, well, that's a long time ago. Why are you hanging on to this particular idea? And we tend, as engineers, we tend to be very experientially driven. We tend to be our feelings about things tend to be based on how easy they were to pick up. I talk to a lot of people in the Go community and beginning engineers in the Go community are very excited about Go because it's very easy to start to learn. And as a result, they're very fanatically loyal about Go. And sometimes to the point where if you tell them about its problems, they get very upset. But generally speaking, we pick up things based on those experiences. So what I'm trying to do here is talk about using the JVM as an example, and I will dive into the things that your colleagues, particularly your operations colleagues, so this is hate about the JVM, but I also want to sort of use it. You can use the same approach to look at other parts of the stack that people don't like based on their experiences. Who knows what the JVM is? Oh, that's good. That's a lot of hands. The last time I gave a variant of this talk, there was not as many hands. So I'm going to very quickly step through some background. The JVM is the Java virtual machine. For those of you who don't know, it's an abstraction layer. So like most virtual machines, it is a layer that translates code or bytecode into machine instructions on a bunch of different operating systems and platforms. It essentially presents a common API. It's defined by a specification that's owned by a group of folks, and it, generally speaking, most of you will probably be familiar with Hotspot, which is now Oracle run, but the IBM has J9, and there's a bunch of open source and non-open source implementations. And if you're in the Java world, then almost certainly you probably run your apps, your operations folks run your apps using something like OpenJDK, which is the Open Java Development Kit, which combines Hotspot with the Java class libraries, the sort of standard lib, the Java-C compiler, and ships as a package on a bunch of different platforms. Windows, Linux, probably still on Solaris, frighteningly, stuff like that. And as with all things that are virtual machines and all abstraction layers, there are upsides and downsides of this. One of the obviously intentions behind Java was write once, run anywhere. I think that actually may have been in the marketing materials when Sun first pitched Java to folks. It's sort of true. There are a lot of platforms the JVM runs on, and there are a lot of architectures it does not. It generally, because it is a common API, sometimes you have situations where a platform might have a particularly good bit of technology you can't take advantage of because you're being reduced to the lowest common denominator of the API. Most principally, it supports Java, as you probably know, but it also supports a bunch of other languages, Clojure, Scala, Groovy, Kotlin, and ported languages like JRuby and Jython. So where do the feelings about this come from? And why do folks have differing feelings? So this is very much in the vein of a lot of the conversations that happen in the DevOps community, where two groups of people feel very strongly about the same piece of something, and as a result don't work very well together. So most of you put up your hands, and I was pretty sure that almost everybody in the room was going to put their hand and say they're a developer. Who here thinks that Java is a good programming language? A lot less hands, but quite a few. Who thinks the JVM is a pretty performant, cool thing? Yeah, several hands. I guarantee you if I gave this same talk at, let's say, a DevOps Days, or at an operations conference like Lisa, there would be significantly less hands come up, because developers tend to look at things in terms of like, I like the language, it's something I can use, I can produce quality content or quality features quickly, and then I ship it off to somebody else and they deploy it. Operations people are at the sort of the next step in the line there. So they don't see your cool feature, all they see is an artifact or a thing that they have to deploy and then manage. So they can have very different feelings about the same piece of technology. And some of this talk is really about providing them with answers to some of those questions. So why so much fear? Well, firstly, I think it's almost impossible to talk about the JVM without talking about why Java disturbs some people. And for those of you who are developers, some of this will be somewhat simplistic. But for a lot of operations folks who come from very different backgrounds and very different experiences, it's a relatively common feeling. Also, there is a sense, perhaps less so in some places, but certainly the open source community, that Java is a somewhat proprietary and not a good citizen. This is a quote from Linus Torvalds, who, in his normal, tactful, subtle way, Java, I don't care about, what a horrible language. He has never said anything about the JVM that I could find, but it is written in C++, which he also describes as a horrible language. Linus hates a lot of things. I don't know whether that's a Finnish thing or not, or just a kernel developer thing. But generally speaking, there's a lot of dislike for the language. And legacy Java, for a lot of folks, is not a lot of fun. This is an actual line from the Apache Web Services XML RPC stack. There is allegedly a line of code in there somewhere that says request processor factory, which is both evil and incredibly annoying. But for a lot of folks, they find Java verbose and repetitive, particularly if they come from a different place. So a significant number of operations people, most of their bread and butter development is done in languages like Go and Ruby and Python, and it's very easy to parse those. As a result, there are lots of challenges. I suggest that a lot of those languages have weaknesses both in terms of performance and stability because they're somewhat more simplistic, but they're very easy to grok. So they're very easy to understand. So for many people who approach the JVM and Java specifically, they're like, I don't like this. This feels very heavyweight to me. I have to page through multiple lines of multiple pages of code before I find something I understand, and it's quite hard to puzzle out. But it's more than just Java that upsets folks, and particularly upsets operations folks. And principally, I'm going to dive into the bits of the JVM that upset people. I talked earlier about the fact that a lot of this stems from deployment. So you write your code, it's perhaps then uploaded to GitHub or put in a repository somewhere or a VCS of some kind. It's then built into an artifact and given to somebody to run. The built into an artifact stage is where the first point at which most people go, oh my God, what is wrong with this thing? And the very first build tool I worked on in Java was Ant. Anyone here worked on Ant, built Ant things? Does anyone like Ant? Yeah, I think the hands that were up were somewhat sarcastic, but I actually have colleagues of mine who I can trigger to have post-traumatic stress moments when I talk about some of the Ant things that I built and they had to maintain. Maven is somewhat better, but still has its challenges. Anything that writes its configuration in XML is evil, honestly, I'm not just saying that as someone who spent a long time as an infrastructure engineer. It is a pain in the ass. So for a lot of people, they're already trying to work out how this thing is built. The dependency models are not transparent. It's not easy to work out exactly what's happening in many cases. And for a lot of folks too, once they get the artifact, it's not an easy thing to actually ship around and deploy. So unlike a simple thing that is let's run the binary and it runs, which is the sort of classic model that most sort of operations people are used to. It's I run Apache by typing Apache 2 and hitting enter. Java requires you to actually have, the artifact itself that needs to run on top of the JVM. It needs to be configured in a container or executed in some way that is somewhat more complex. So there's a bit more steps in the middle. From a performance point of view, back in the day, and I'm talking largely about, anyone remember Java 1.1? Did anyone work on Java 1.1? There's a few other bald dudes in the audience going, yay. Till about Java 1.4. Java's performance was flaky on occasion, and certainly flaky in some very specific instances. There's a saying in engineering that you get consistency, availability, and integrity. Choose one. Under the Java 1.4, I was always choose one maybe. Certainly in terms of 1.4 startup time, its performance, its memory leaks, there were a lot of challenges. So a lot of people have memories of okay, I run this thing and I hit enter to launch the application. I'll go and get a cup of coffee while it unpacks things in jar files and does things and launches things and then eventually spits out a message saying there's an error. And that's an extremely frustrating experience for folks. But it was made worse by the fact that tuning an actual, I'm not sure what I think I just dumped settings, but tuning the JVM is not a transparent exercise, or certainly wasn't a transparent exercise. There are a lot of configuration options that do strange things. There are a lot of configuration options that are labeled in ways that you're what does this name actually mean? I have to dig through a pile of documentation to determine that this particular garbage collection attribute only works when the moon is full, during the solstice, and when I throw some ash on the fire and run widdershins 3 times around the pot. And there are significant numbers of these sort of problems where you come online and if you look at sites like, not Quora, the other one, Stack Exchange, you find a lot of folks going, how do I do garbage collection? What does this garbage collection mean? How do I assign memory to an application? In a way that is not transparent in the same way that other services that of operations people run. And that leads into a larger problem for a lot of folks that the JVM was operationally complex. So it's difficult to configure. It's very hard to template. One of the things I built early, well, not early, but one of the things I built or was partly responsible for building is Puppet. Anyone use Puppet? A couple of hands. It's a configuration management tool. So if you don't like it, it's not all my fault, mostly Kinesis' fault, but I generally am responsible for some of it. And one of the things we did as part of that exercise was to try and build an abstraction layer or a domain-specific language for configuring and running JVM-based applications. And unlike building something that allowed us to create an abstraction for, say, running an Nginx website or an Apache website or a MySQL server, we've discovered that there were enough subtleties and differences that it was very hard to create a common API and a configuration management tool. And that frustrates operations people enormously because they feel very much like I'm having to create a custom solution for something. And what's worse for the operational complexity thing, and I get in a lot of trouble for this slide, and I expect I had to apologize to one of the Log4j developers and add the one in there because I rudely dropped the one part. But the original release of Log4j is awful and it's incredibly hard to configure. It does things like when you want to reconfigure it, it may drop some log messages. From my point of view, anything that drops log messages, that's a bad bit of software. It's hard to put properties on. It's hard to annotate. And has anyone ever here tried to create structured logging output from a early Java application? It was not an easy exercise. And as a result, like you are at scale, you are reduced to producing human-looking things. For a lot of sysadmins too, when the JVM carks it or has a problem, the error output is not a lot of fun. This is an actual Groovy stack trace. I spend most of my life living between sort of JavaScript and Ruby these days, a bit of Go and a bit of Clojure. I would take a Ruby stack trace any day over the top of a JVM stack trace. They are extremely intimidating to look at. It's extremely complicated to work out what's going on, particularly if you're not close to the source code or you didn't write it yourself. It's a very different experience. To make that worse, when you're actually looking at a bunch of these, the application actually running, the JVM was not very observable. So there are a lot of surface metrics, but it's actually quite hard to poke in it was actually quite hard. I'm having problems with my tensors. It was actually quite hard to poke inside the JVM and see what was actually happening and debug things. A lot of it was not necessarily the JVM's fault, but some applications were not necessarily instrumented well. But where you lacked that instrumentation, there wasn't a way to poke in and see what was happening. Garbage collection metrics are my classic one here. They may mean what you think they mean and they may not. And in certain cases, people make assumptions about how they should fix something based on information where their understanding of what that information is, the tenets of that is incorrect. Security, operations people care about security. That's probably why they tell you no a lot. They shouldn't, and they're getting better at it, they promise. But they tell you no a lot because they've had bad experiences where things like the JVM was basically configured, and container things that ran on top of the JVM, like Tomcat and Glassfish, were basically configured open by default. Anyone here build browser applets, Java applets? What I describe largely as a vulnerability rather than a feature. These sort of things that make people very annoyed, particularly operations people. And there were patches in there. My favorite one is thread stop. Thread stop used to go, okay, I'm just going to kill all of these threads and drop everything in the state that it's in. Security people go, what the fuck? And okay, I'm Australian, bad words will come out of my mouth every now and again, I do apologize. But a lot of security people are like, what the hell? Why would it do that? Leave the application in an inconsistent state and leak potentially valuable information all over the place. That is behavior that is really poor and very frustrating for folks. And there are certainly, I can trace back at least a couple of incidents I've heard from people where they can trace back to one method call. They're like, this sucked. And I will say that Sun and then Oracle, how do I say this without getting in trouble? I'm gonna say it anyway. Don't have the most awesome history about security disclosure and the speed at which they released security updates. I don't think I'm talking out of school there. This is not a security conference, but there'll be a bunch of security people who, if anyone watches that video, will be nodding and going, those bastards, they made us very miserable. And so, as a result of that, and of those collection of things, for many operations people, the JVM is completely inscrutable. And it means that for them, it's something that they look at and go, okay, I don't want to work with this thing because either it went badly wrong or someone I know has talked about something that went wrong. So basically I've laid out a bunch of things that are about what the JVM like, a bit about Java, a bit about how it was perceived, and how certainly there's a lot of mythology and experience about where people have taken all of those problems and basically said, this is a stack that I wish my developers didn't build upon. So we're going to have a little bit of a palate cleanser to make everyone feel a bit better, because I hopefully didn't I may have depressed some people. Here is a Kitten. The Kitten is not thinking about the JVM. I think the Kitten is thinking about this lovely thing running around here. Here's a fox. Fox is also not thinking about the JVM. Here is a spider. Spiders are evil and scary, so that it may actually be thinking about the JVM, but I try and put one in every slide to overcome my terrible fear of them. So, what's changed and what can you tell the people who have those feelings about the JVM? The news is good. And a lot of those folks, I've been addressing some of them one-on-one and pointing some other people at videos of talks like this. But there's an opportunity for you to be, when the next time you hear someone say the JVM is crap, is to say that things have changed. Yeah. One of those things is what I will describe as modern Java, and by this I mean Java 8 onwards. I didn't believe I'd ever be saying this, but I find writing Java 8 and 9 mildly pleasant, and that's not a comment that I ever expected to make. Sorry, my slides are... It's, yes, not your great aunt Smellman's Java. It has a bunch of things in it that if you come from a different background, are concepts that will make you feel a bit more comfortable and a bit more expressive and a bit more easy to consume. Lambda expressions, method references, stream API, a bunch of stuff that from my perspective, makes the code that I see more consumable and easy to understand what's happening. In the deployment space, we've gone a long way. The latest release of Maven is non-XML configuration. I was very excited about that, and a significant number of improvements have happened over the course of development, starting with stuff like Uberjars and leading to things, even stuff like Docker and stuff like that, that make it much easier to ship those artifacts around and ship a JVM or a JDK or a runtime environment for them to run on top of. Also things like, if you're Gradle, which is a Maven with a groovy DSL, and if you in the closure world, Liangen, which I always pronounce wrong, but I have a deep affection for, has made life considerably easier. So if your previous experience was Apache Ant or early Maven stuff, and if your operations team experience is that, look at porting those build things to more modern things. Now, one of the other really cool things is most of the modern CI tools. It's not just Jenkins that supports Java, and getting Jenkins to test things reliably on Java back in the day was not a fun experience. But things like Travis and Circle natively understand what's happening. Not perfectly, but natively understands what's happening. So it's much easier for people to build CI pipelines and do deployments. It's much, much faster. I was looking at some stuff the other day on the just-in-time compilation stuff, and it is significantly faster than 1.4 and earlier releases. A lot of garbage collection stuff just works now. I can't remember, somebody said in Java 9 that it was going to be self-tuning. I don't know what that means. It sounds really cool. I think it's like saying it's powered by artificial intelligence. It's probably not true, but it's kind of cool to hear. And it probably means they've done a bit more work on making things to manage themselves a little bit better. Logging is a whole new world, and one of the reasons I had to apologize to Log4j core developer was that Log4j 2 is a significantly improved tool. Prove reliability alone, when you reconfigure it, it doesn't lose messages. That's a pretty cool thing to me. It's a much simplified configuration syntax. It's very easy to add properties to things. It's very easy to produce a log output that's actually consumable. And there are now lots of other tools around there too that help you turn that log output into structured logging. If you're not producing structured logging, you should. Humans shouldn't read log files. Computers should read log files and put them in sensible places you can create graphs from, or look at, or search or parse rather than string output. It's also significantly faster. Observability has been significantly uplifted. This is one of the areas that every now and again I am using some of the tools that are now available, and I'm literally blown away by their capabilities. And I have serious envy about the fact that I would have loved these tools 10 years ago. JMX and managed Java beans. You do not have an excuse to not be able to instrument applications. It's relatively easy to do. It's XML configuration, yes, but there's a bunch of tools out there that can template stuff like this. Collect is a good example. There's Puppet and Chef and Ansible modules that allow you to add JMX to a JVM install. JStatD, which I deeply love, makes a bunch of this stuff, surfaces a bunch of this stuff, produces little graphs and sparklines and a bunch of other things that has made my the remote management stuff considerably simpler, particularly if you're operating a large number of instances. The day of being able to having to flip between multiple screens to work out what was going on was definitely not a fun experience. And JStats, which attaches to either the daemon or to a debug server and spits out garbage collection stats and things like that. JMap, who likes debugging dump files from Java? Is there anyone in the room that thinks that's an activity that's a quality time? I do not, and I find that the ability to be able to print out that state of memory and find out what's happening in a way that previously was not incredibly simple, or was only when I'm doing stuff when something had gone wrong. And heap dump, some of these are fairly self-explanatory. One of the other challenges that I always found was out-of-memory errors are not easily understandable by mere humans on occasion, and being able to actually understand what's happening is a relative. And again, being able to do stuff like JHat, which is a web server that you put a dump into, it spits out a bunch of information and presents it in a live web server that allows you to actually poke through what's happening in real time and understand what's going on, which has saved significant sort of experiences. Dumps in final configuration, JSDebugD, JStack. Yeah. So a lot of these things have emerged in the ecosystem in the last few years and have been shipped in the last few releases of things. And a lot of the stuff you'll probably be saying, but don't they have an IDE and the code? In many cases, operations people do not. They are literally inheriting an artifact. And they do not have an ability to open up Eclipse and open up the source code and step through and breakpoint things and things like that. So having the tools that suit the things they need to do now makes things significantly easier. Security has been taken seriously in the last few releases. Things are closed by default. It's much easier to apply things like SSL. There are definitely some of the encryption issues have been removed, and more modern encryption algorithms are actually being exposed. There are still some guilty parties where some things I'm like, oh my God, why do you still have that? No more applets. They were deprecated in Java 9. Seems like a long time to me, but a significant step forward. And overall, it's much easier there's a lot more configurability around security, and it's a lot easier to understand what's happening. So rather than being inscrutable, the JVM is now lit. It's now really easy to actually interpret and see what's happening. And a bunch of the tools that are available I actually, I started poking through the documentation for, and started talking to a bunch of people, and they were like, never heard of that, had no idea that existed, because I gave up trying to debug things in that particular way. So it's worth pointing your operations teams at things, saying there is a cohort, a huge ecosystem of tools that have developed that's going to make your life significantly easier if you are the person that gets up at 4 o'clock in the morning to debug the problem. So in summary, the new JVM is awesome, and it really is, and we proved it. And I must admit that in a way that I never quite appreciated before, it is actually a platform that I strongly encourage people to look at and recommend. And that sort of leads me to try and tackle the first part of this original statement, which was about mythology and about experience. So if you're having that conversation with somebody, it's like, we're going to build a new thing, or we're going to extend this new thing, or we're going to refactor this thing. And that's a conversation that's happening a lot at the moment, particularly around microservices and things like that. A lot more patterns have emerged where people are saying, I'm going to take this legacy monolithic application, I'm going to turn it into services. And a lot of the times that I've had that conversation with folks, the response has been, we're going to build it in Go. I'm like, why? And it's like, the original app's in Java. Why do we have to retrain a bunch of Java developers to write Go? And they're like, oh no, Java's way too heavy and JVM is way too heavy to run a service. And I'm like, that is bullshit. And it's based on your previous sort of stereotypical views of the platform and the language. And you need to stop doing that. And it's much easier to path collaboration. When I was at Kickstarter, we broke down a monolithic Rails app into services. And we chose we chose a couple of different languages to do that. One of the languages we chose was Java, because we had a bunch of folks who wrote Android apps and knew Java, and we're happy to teach it to people. But when we actually, because one of the principal reasons was when we can put side by side, particularly at scale, at large volume scale, the JVM blew pretty much every other solution out of the water performance-wise, which was quite a shock to the DevOps team. They were very, very surprised. They were. I think I had to pry a Go from their cold dead hands, but they were quite stunned by the experience. And I find that if you're doing architecture by mythology, if you're doing that, if you're building stuff because you have a group of people who feel fundamentally that a piece of technology is not good, despite this not being reality, then this is not a great place to be in. It particularly leads to the sort of conversations that DevOps was designed to try and counteract, which is, you chose a shit thing, you then made me implement the shit thing, and now it's behaving in a shitty way. Like, why would I want to talk and collaborate with you? Whereas instead you can go back and say, okay, this is why we chose this stack and this platform. Here are the tools available to you. It's not the same thing where you got hurt previously. You think there are ways to get past this, and there are ways to build things. This is a quote from Hegel, who is a very cynical German philosopher. We learn from history that we do not learn from history. Prove Hegel wrong. Take those historical experiences, advance them into the 21st century, and then proceed to actually build things by logic and not mythology. Questions? Thank you. Sorry, my glasses are a couple of things behind, so I have to read this up close. Would JVM be as popular if it appeared in the market at the same time as easy-to-use compiled languages, Go, Rust? I think there's definitely a different set of use cases in some regards. I actually think that there are definitely things that you can do, and the fact that there are multiple large volumes of applications written on Java in enterprises, that there's a level of maturity you get that you don't get with Go and Rust. C++, I think if I was to toss up build an application and I had a bunch of people who were C++ and Java, I don't know, it would be a hard decision to make these days. Next question, with a typical Java stack, it is still painfully slow compared to pretty much anything else. I don't know. Again, this is pretty much a question that I see every now and again. I don't know how to answer this question. Your circumstances may vary. That has not been my experience. I don't know what a typical Java stack running on that particular platform. I'm happy to talk about problems, and there are plenty of people out there, ThoughtWorks and Pivotal and stuff like that, who have deep experience in solving stuff like that. I'm not convinced that that is an objective statement. I think that's a very subjective statement. Any thoughts about Java on mainframe? Is it a good idea? Honestly, I think anything on mainframe is not a good idea. So my very first job was a mainframe operator in 1980 something, and they take up a lot of space. They cost a lot of money. They definitely take up a lot of real estate and power and lots of things. They tend to be monolithic. You probably should get rid of them in favor of other things. You know, the world is moving towards mobile and the web, and you can't stuff a mainframe in your pocket next to your phone. How to investigate a Java 8 metaspec? Not easy, still. I'm not quite sure. I would happy to sit down with someone afterwards, but I'm not sure I can answer this without diagrams and pointing. Have I killed all of the questions? I think I have. All right. Okay. Thank you so much for coming. I hope it was useful. I'm aware of the fact that as developers, many of you, I'm preaching to the converted, as it were. But I'm sure you work with people who have these feelings. Please go back to them and say there are things that you can do to make this better. And go forth and enjoy the rest of the conference. Thank you so much.